Hi, Bobcats. In this video, we're going to work examples of writing and balancing chemical equations. I also have to confess that the way I'm presenting this also sneaks in a review of nomenclature from chapter 4. Our objectives are twofold. The first is we're going to turn the names of substances into formulas. That's the sneaking in the nomenclature. And then our second objective is to correctly write and balance these equations, making sure that we are using the appropriate notation like coefficients, the plus sign, and the arrow. Our first example says in the Haber process, nitrogen reacts with hydrogen to make ammonia. So we have to convert these words into formulas. Nitrogen reacts with hydrogen. That tells us that those two chemicals are our reactants. Nitrogen has a symbol N, and it's a Brinkelhoff, so we have to put a subscript of 2 on it. And then hydrogen has a symbol of H, and it also is a Brinkelhoff, so it needs a subscript of 2. And these two guys react together to make ammonia. Ammonia is one of those weird compounds that the common name became its official name. So ammonia is NH3, and that's one you really need to know, just like water is H2O. So now we're ready to balance this. It looks like we have a little bit of that even-odd problem because hydrogen has a subscript of 2 on the left side, but on the right side it has a subscript of 3. So I'm going to fix that by making the hydrogens on the right an even number by putting a coefficient of 2 out in front. And 3 times 2 is 6. If I look at hydrogen on the left-hand side, I only have 2 of them, so I need to put a coefficient of 3 out in front. And then last but not least, let's look at the nitrogen. Over on the left-hand side, there are 2 nitrogens with the N2, and on the right-hand side, there are 2 nitrogens because there's a 2 coefficient out in front multiplied by the subscript of 1. So 2 nitrogens on both sides, and this is a correctly balanced equation. Now, one of the ways that I will ask about balancing equations on a test is by asking you for the coefficient in front of one of the chemicals. And so if we go from right to left on this, ammonia has a coefficient of 2, hydrogen has a coefficient of 3, and nitrogen doesn't have anything written out in front of it. So when nothing is written out in front, it's understood to be a 1. If it was a 0, nitrogen wouldn't even be in the equation. So it's a 1 when nothing is actually written. So to demonstrate this, if you remember the Haber process from the previous slide, we had nitrogen plus 3 hydrogens yield 2 ammonias. And so the coefficient that we are looking at or looking for is the 2. So that would be the correct answer. In this example, we have hydrogen reacts with oxygen to make water. So hydrogen reacts with oxygen, there are our reactants, and then this phrase to make water says that water will be on the product side. So hydrogen is a Brinkelhoff like we saw in the last example, and then oxygen also is a Brinkelhoff. And water, like ammonia, is one that you just have to know. Water is H2O. Now, I forgot in the last example to draw a box at this point. Once you have the formulas written correctly, if you're struggling with balancing, it may help to draw a box around here to remind yourself the only thing you can balance with are the coefficients that you write out in front. You cannot adjust the subscripts. If we were to change either one of the subscripts on water, the chemical would not be water anymore. So now that we have water correctly written, we want to balance with coefficients. If I look at hydrogen, over on the left-hand side, we have 2 hydrogens, and on the right-hand side, we have 2 hydrogens. On the left-hand side for oxygen, we have 2 of them, but on the right-hand side, we only have 1. So I want to fix the hydrogen and the oxygen on the right-hand side by putting a coefficient of 2 out in front. And now I'm going to have the oxygens fixed. But the problem in fixing the oxygens is now I've messed up the hydrogens, which were previously balanced. Now over here on the right-hand side, I have 2 times 2, which is 4 hydrogens, but on the left-hand side, I still only have 2. So I've got to fix that on the left-hand side by putting in a coefficient of 2 out in front. So we have 2 hydrogens plus oxygen yield 2 waters. Another way that I will ask about writing and balancing equations is to ask you for the sum of the coefficients. So that previous reaction was 2 hydrogens plus oxygen yield 2 waters. And if we're going to add up the coefficients, we have a 2 from in front of hydrogen. And in front of oxygen, even though we didn't write it, there's a 1. So you got to remember to put the 1s in there. And then in front of water, we have another 2. So the sum of the coefficients in this reaction will be a 5. Another example of a reaction is that butane burns in air to make carbon dioxide and water. Butane is the fuel in a lighter, and so this is the reaction that's going on every time you flick your Bic. So butane has the prefix but, which indicates 4 carbons, so it's C4. And then to get the hydrogens, we double that number and add 2 more. So 4 times 2 is 8, plus 2 more is 10. Burning in air means that it's reacting with the oxygen in the air. And then carbon dioxide is a covalent compound, so the prefix di tells us there are 2 oxygens, and the other product is water. To balance this, over on the left-hand side there are 4 carbons, so I need to put a coefficient of 4 in front of carbon dioxide to balance the carbons. Since oxygen appears in 2 different chemicals on the right-hand side, I'm going to wait and do oxygen last. Let me balance hydrogens first, and then we'll tackle oxygens at the end. So on the left-hand side, there are 10 hydrogens. On the right-hand side right now, there are 5. I'm sorry, there are 2, so I need to put a coefficient of 5 out in front to make that balance. And now if I try to add up all of the oxygens on the right-hand side, there are 4 times 2 in the carbon dioxide, which is 8, plus another 5 oxygens from the water, so that's 13 oxygens. And now I've got a problem because over on the left-hand side, my oxygens only come in even numbered amounts because of the subscript of a 2. So I need to look back at the product side and do something to change my odd number of oxygens into an even number. So when I do that, I need to change that coefficient of a 5 into a 10. And now that I've changed that, I'm going to have to redo hydrogens because changing the coefficient of a 5 to a 10 doubles how many hydrogens there are. Now there are 10 times 2, which is 20 hydrogens. So over on the left-hand side, I need to put a coefficient of 2 in front of the carbon, and the 2 times 10 gives us 20 hydrogens. Now for the carbon, I just messed it up. So now I have 8 carbons instead of 4, so I need to change the coefficient in front of CO2 to an 8 to make the carbons balance. And now let's tackle those oxygens one more time. On the right-hand side, I have 8 times 2, which is 16 from CO2, and then I have 10 times 1 from the water, so I have 16 plus 10 is 26, and so that means I need to put a coefficient of 13 in front of the O2 because 13 times 2 is 26. Silver nitrate reacts with barium chloride, so those are our reactants, and it's going to produce silver chloride and barium nitrate. And these are all ionic compounds. It's a metal plus a nonmetal. Silver's fixed charge, it's a +1. Nitrate is a polyatomic ion, NO3 -1. Barium is a group 2 fixed charge metal, so it'll be a +2, and then chloride is a -1 halogen. Okay, so if I'm going to write the formulas for these compounds correctly, I'm going to have to crisscross to make sure that charges balance out. Since nomenclature isn't the primary focus of this lecture, I'm just going to go ahead and write the correct formulas. If you're not sure where I got these, make sure you go back to chapter 4 and review ionic nomenclature. So silver nitrate is going to be AgNO3. +1 and -1 cancel out, so that's fine just like that. Barium chloride is going to be Ba and Cl. After I crisscross, we end up with a 2 on the chloride, and then they're going to make silver chloride, which is AgCl, and barium nitrate. When we crisscross on this, we end up with 2 nitrates, and with the polyatomic ions, if you need more than one, you need to put it in parentheses. To balance this, right now, it looks like there's 1 silver on each side. If I tackle nitrates next, there's 1 on the left and 2 on the right, so I need to put a coefficient of 2 in front of silver nitrate, which now messes up the silvers. So I can fix the silver by putting a 2 in front of AgCl. That's going to give me 2 chlorides, and if I look at the left-hand side, we have 2. The only element we haven't looked at is barium, and there's 1 barium on the left and 1 barium on the right. Every once in a while, when you're balancing equations, you will end up with a set of coefficients that can all be divided through by the same small number. If you end up in that scenario, you need to reduce the coefficients. Otherwise, the equation is not considered correctly balanced.
In this example, the reaction appears to be balanced. Let's count the atoms to demonstrate that. On the reactant side, we have nitrogen atoms in the nitrogen molecule, where we have 3 molecules. So 3 times the subscript of 2 gives us 6 nitrogens on the left side. Over on the product side, we have nitrogen and ammonia, and the coefficient out in front is a 6, so we have 6 nitrogens on the right-hand side. For hydrogens on the reactant side, we have 9 times 2, which is 18, and on the product side, we have 6 times 3, which is 18. So it all looks good. This is all balanced, right? Well, this is considered balanced, but it is not considered correctly balanced. After you balance an equation, you want to double check that the coefficients cannot be reduced. In this case, the coefficients of 3, 9, and 6 can all be divided by 3, and you should reduce it. So if we divide them all by 3, the coefficient in front of nitrogen becomes a 1, the coefficient in front of hydrogen becomes a 3, and the coefficient in front of ammonia becomes a 2. This issue pops up on your Sapling Learning homework. There is one problem on the homework where Sapling Learning leads you down the path to come up with a balanced equation where all of your coefficients have a common factor. And so you need to reduce that on the homework. And you're going to get so frustrated because you're looking at this and you're saying, but wait, this equation is balanced. And yes, it is balanced, but it's not correctly balanced. Anytime you can reduce your coefficients, you should.
And finally, our objectives were to turn the names of substances into formulas. That's all about nomenclature rules. And then to correctly write and balance equations, including using coefficients, the plus sign, and the arrows.